Now in this tutorial we will perform a linear buckling analysis. Consider the following problem. Starting with creating material as steel, putting the default value. Since we are performing this in the 3D elements, thus making a property as 3D, type as 3D, card image as P solid, material as steel, and create. After that we will create the plane and drag them to create the 3D elements. Placing the nodes, go to the surface and create the surface through node list. Spline filler. Mesh the following using the 2D elements of 5 and drag this in the 1000 mm. Since elements are in the size of 5, the 200 elements will be okay, and drag them. We have created the 3D elements. After dragging, delete the 2D elements. And clear the nodes. After that, go to the analysis page and create the constant. It is created in the load collector named as auto, and create another load collector as method struct, selecting a card image named as EIGRL. Go to create edit, put v1 as 0, nd as 2. This is requesting how many mode shapes we are going to have. After that, create another load collector name as stat without any card image. Before giving the static load in this load collector, go to the force and select the element of these sides and nodes of this side. Put the direction and create. Now create the load step as static, type as linear static, SPC as auto 1, load as stat. Create the another load load step as linear buckling, SPC as auto 1, method is struct as methodo, and the static subcase as static. Static subcase is the load step created earlier, and create it with another name as buckle. After that, update the property of component and run the analysis. It is showing the maximum displacement and maximum stresses of static subcase. Now open the Hypermesh and view the result for static subcase. View the contour. This is for static. We can view the animation. Now for the buckling, select the subcase 2 named as buckle and view the contour. We can maximize the scale of deformation through here. Adjust the frame rate by this option. We can also increase the number of steps for the animation. Since our analytical answer was 863.59 Newton and our this answer was 5.74, which is very different from analytical answer, thus we made some mistakes. I think the mistake may be in the constant we created, because this beam is flying. Thus update the constant, go to the constant page and take all the degree of freedom. Earlier it was ticked only degree of 2, DOF 2 and DOF 3, but we have to restrict this in all degrees of freedom. Thus create another constant and run the analysis. Also the load is taken as 1 Newton in the beam, so update the load also by deleting the previous load collectors. And creating the new forces of magnitude 0.06666 as calculated node on the each node. Select the 15 nodes of top, and create the loads. After that run the analysis. It is showing analysis completed. Let's view in the hyperview and select the subcase 2 and see the value of force, which is exactly same as the analytical answer. Here is the buckling analysis. Contour, showing buckling modes, mode 1 and mode 2. Showing buckling in different direction.